So let's continue with the drivers A to Z DSA course, and today's problem will be involving the concepts of two-pointer and the sliding window. But before starting, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is longest substring with at most k distinct characters. So what is the problem stating? It's stating that it'll be given a string, it'll be given an integer k. Now your task is to figure out the longest substring. Now what is the definition of substring? Any consecutive portion of the string. For an example, this is a substring and the length is 4. How many distinct characters does it have? It has 3 distinct characters. A, B, C. 3 distinct characters is not allowed. At most 2 characters. So this substring is not a valid one. Now your task is to figure out the longest one. Can I say this substring is a valid one? I can, because the length is 4 and it has 2 distinct. So this is a valid one. Can I figure out a better or a longer one? Yes, I can take this one. This has a length 4 and it also has 2 distinct characters. So this is a valid one. So you'll have to return the value 5. So what is the extreme naive solution that you can think of? Explore all the substrings, correct? So you know one thing, the first substring will be this one. And then eventually you can add this, all the characters to the right, and you can generate all the substrings that has the starting character as A. Now to get the next set of substrings, what you can do is, you can start with the next character and then again keep on adding the right characters to it. So you'll get all the substrings. And to get the next set of substrings, you can again start with this and attach. So you'll get all the substrings starting with this. So I can generate all the substrings, correct? Now when I generate, I'll have to keep a track of k distinct characters. It's going to be very simple. So let's say you start with this A. What you can do is you can take a map data structure. And you're starting with this A, you can put that A with its frequency in it. And after that you can go to this A and you can increase the frequency. After that you can go to this A and increase this frequency. After that you can go to this A and put it into the map. After that you can go to this B and again put it into this map. After that you go to C, and the moment you put it into the map, what happens is the size of the map turns out to be 3, and that is not allowed because at most you're allowed 2 distinct characters. So you can stop attaching and you can break out. And after that what you can do is you can erase the map. Yes, this is what you can do. You can erase the map and you can again start with this particular A. And again you can start attaching till the map size doesn't exceeds the value k, and you can keep on doing, and in exploring all the substrings, the longest you get, that's going to be your answer. So that is a typical brute force. We have done it a lot of times. So let's quickly write down the pseudocode. You'll be given down a function, you'll be given an s, you'll be given an k. What we do is we start, or maybe we can keep a max length as 0, and what we can do is we can take a map data structure over here, and this is going to store a character and an integer. Very simple. After that, what I can do is I can straight away start from I equal to 0 and I can iterate till n. Why do I start from 0? Because this element can be considered as my first, this can be considered, and so on till the end. So I consider every character as my first element once. After that, what I can do is, if the map has elements, I can just clear it off because I'm starting off a new set of substrings. Perfect. After that, what I can do is, rather I'm starting off a new substring, I can start picking up the elements. So the first element I pick up is itself, I itself, and I go on picking up till the right. And what I do is map of s of j plus plus. And after this, what you can simply do is, hey listen, if map of size is lesser than equal to k, it's a valid one. And if it's a valid one, you can just update it to max length. If it exceeds your max length, so you can write max of max length, comma, the size will be j minus I plus 1. Straightforward. But if it doesn't exceed, you can stop attaching because you don't have k, you have more than k. There's no point in attaching the elements from the right. You can straight away break, the for loop can end, and you can return your max length and the function ends. This will be your pseudocode, and if I discuss the time complexity, it's going to be super simple. A big O of n, somewhere near about a big O of n, So n square, and if you consider that the map is taking some time complexity, and depending on what the string has, if it has uppercase, lowercase, depending on the size of the string, at max you can be given all characters in English alphabets. That's 256. So if you assume that your map is taking logarithmic time, so it will be logarithmic of 256, because that is the maximum size of map that you can have, because you're storing 256 English alphabets, not more than it, right? And if it is given that you're just given lowercase, this will boil down to 26, depending on what characters you'll be given according to the constraint. This logarithmic will boil down. Again, if you're using something like an unordered map in C++, the map time can be a big O of 1 as well. What about the space complexity? Using a map, so 256 at the worst possible scenario. So this is the brute force, and obviously the interviewer will not be happy with this. I'll ask you to optimize this one. So we need to optimize n square into something better. Now when I say something better, it typically means somewhere around big O of n. And the question is involving substring. So yes, you guessed it correct. We'll be using 2-pointer and sliding window technique over here. So the typical way to start is, you all know, you take a L, you take a R, and you put it at the 0th index. What are we looking to count? The distinct characters. So we'll be requiring a hash map as well. So maybe take a hash map, which is going to store a character and an integer. We need to store the max length as well. So maybe take a max length, which is initially going to be 0. We are standing at first, like the 0th index, which is having A. Take that, put it into your hash map. Done. The next thing is, check if this is a valid one or not. Is this a valid window? Is this a valid substring? You go to map and you ask, hey, how many distinct characters do you have? The map says 1. And I say, that's allowed. And if that's allowed, you update your max length to 1. Perfect. What is the next thing? You pick up your R and you move to the next. So A increases to 2. Done. Once you've done it, you check if this is a valid segment or not. You ask the map says, I have 1 distinct character. That's valid. So what I'll do is I'll update the max length to 2. Next, you take the R and you move it again. So A becomes 3 this time. So when, maybe I can just erase it. So A becomes 3. This time again you ask, hey, is this a valid segment? I again go back to the map. Map says the size is 1. Hence, it's a valid one. So the length gets updated to 3. Next, you take the R and you move it to B. So B will be put into the map, right? Again, you ask, is this a valid one? You go to the map. Map says my size is 2. And that's allowed. So you update the max length to 4. Next, you take this R and you move it to B. Again, this will increase to 2. And if it increases to 2, the next time you say is, okay, is this a valid one? The map says 2. It's a valid one. So the length increases to 5. Perfect. And that's the longest one. After that, the R increases to the next one, which is C. C is put into the hash map. So when C is put into the hash map, what happens is you see, okay, I have a length 6. Is this a valid segment? And it says the size is 3, which means it has 3 distinct elements, which is not allowed. Hence, it is not a valid segment. Hence, max length will not be updated. Now, this window is no more valid. So please make sure you make it valid. How can you make it valid? We take out 1A from it. So if you take out 1A from it, what will happen is the frequency will decrease to 2 and the L will move to the front. Okay. At this moment, you again check, hey, is this a valid scenario? And again, when you look into the map, it says my size is 3. I'm still not valid. So if it is still not valid, what you'll say is, okay, maybe remove this A as well. So if you're removing this A, this decreases to 1. Perfect. And then again you move this. And again you ask, hey, is this a valid scenario? And now you're saying, let's look into the map, and map says, no, you're not valid. Perfect. Let's remove one more A. So the moment you remove one more A, now this is very important. When this turns out to be 0, and your L is moving one place ahead, which is to here. When this turns out to be 0, please make sure You remove this A from the map data structure. It shouldn't be there in the data structure. Perfect. Next, you ask, hey, is this a valid segment? And it says there are 2 elements. They are valid. But the length is 3, so you do not update the max length. Afterwards, you move the R, and that goes to C. This increases. Is this a valid one? It says, yes, I'm a valid one. The length is 4, so you do not update. After that, you move the R. The 7 goes to D. D gets into the map, and you ask, hey, is this length 5 valid? You go ahead and ask, and it says, no, I have 3, so it's not a valid one. Again, you start removing. So you remove this B. If you remove this B, what happens is this 2 gets decreased to 1, and the L moves 1 place ahead. Again, you ask, is this a valid one? It states no. So again, you remove 1 more B. So the moment you remove 1 more B, the B gets to 0, and you erase it. And if you erase it, the L goes over here, and you ask, is this a valid one? It says, yes, I'm a valid one, but the length is 3, so you don't do anything. After that, you move R, and R goes out of the boundary. So you stop then and there. The max length is 5, and this is your answer. But this is how you can do it. It's super simple. So what I'll do is, I'll quickly write down the pseudocode. Again, if you want your language specific code, you can find them below. So what I'm going to write is a function. Let's write down a function, which is taking a string, which is taking a k. First thing I need is a max length. The next thing I need is the window, L equal to 0, R equal to 0. The other thing I need is a map with a character and an integer. Do I need anything else? No, I don't. What I can do is I can start iterating. So the while loop now goes from R till the size of the string, which is s dot size. Perfect. After this, after this, what I need is, I need to put this into the hash map, correct? That's what I was doing. I'd be like, map s of R, can you go into the hash map? Perfect. Right after this, what I have to do is, I have to check if this is a valid one or not, right? If this segment is a valid one or not. And if it is not valid, I'll have to remove. So I'm checking, and if it is not, I'll remove. So maybe I can write a while loop, which kind of acts as my condition check. Hey, if map.size, if the number of elements are greater than k, that means it's not a valid. If this condition is false, it doesn't execute the while loop. So the while loop works as a if condition as well. Okay, if it is, what do I do? I remove. What do? I remove, I say hash of s of L, can you just get out of the map? And once you're out of the map, please make sure if hash of s of L is 0, that means also get out of the map. I have reduced one value, and I am saying, hey, map, whatever is your value, can you get out of the map? Once you are out of the map, what is my next thing? I'll now move L equal to L plus 1. The while loop keeps on going till it gets a valid segment. Once it has a valid segment, I can straight away write, hey, if, what's the length? The length is R, or rather I can say, hey, if mpp.size, if it has lesser than equal to k distinct characters, max length can be updated to max of max length, comma, j, or rather R minus L plus 1. That's going to be your length. And after that, before finishing off the while loop, for the next step, make sure R moves equal to R plus 1 and the while loop ends. And eventually, you can go ahead and return your max length. That's done for the function. Yeah, that is done and dusted. I will have to figure out what is the time complexity. Now, what is contributing to the time complexity? There is a while loop that is contributing to the time complexity, correct? So can I say that the while loop is taking a big O of n time? I can say that, correct? And there is an inner while loop. So I'm running an inner while loop as well. Now, is this inner while loop taking exactly big O of n? No, it is not. Why do I say that? Because this L, it's not that it's moving n time every time. No. It might move 2 times, it might move 3, it might move 4. But eventually at the end of the day, it will be some segments that it is moving. And throughout it will be moving at the max of n, not individually n times every time. Correct? At the end of the day, if you sum the total iterations of the cell, it might start from here and it might end here at the end. Throughout it might move a big O of n. So I can say that's another big O of n. I'm using a hash map. So again, depending on what hash map are you using, it can take a logarithmic 256, a big O of 1. I'll leave that on you. And the space complexity at the worst can go to 256 if the string is consisting of all the characters. So that will be one of the approaches. So the current approach is taking a big O of 2n. A lot of interviewers will be okay with this, but some might still ask you to optimize it. So if, as an interviewer, I'm asking you to optimize the big O of 2n, that means you have to get rid of this extra big O of n. And that was caused because of this inner while loop. I'll have to get rid of this. So if you haven't seen my template video on two pointers and sliding window, go back and watch it. I have a template video where I've explained how do we start with the brute force, and we go to this while loop, and then we optimize it to big O of n. Go back and watch that template video. That will help you immensely. So what I will do is, I'll follow the same algorithm, keep the L and R, take a map data structure, take a max length to be 0, and I'll start the same algorithm. A gets in, max length is updated, and then R moves to the next. And then A gets updated, max length is updated, then R moves to the next. Again, A gets updated, max length gets updated, and R moves to the next. B gets updated, max length gets updated, R gets updated. I'm going fast. B gets updated, max length gets updated, then R gets updated. And this is the point. When you reach at C, you insert C and you ask, is this a valid segment? And it says it has three unique elements. Hence, it is not a valid segment. So you do not update the max length. Now let's understand. This is your sliding window, which is of length 6, correct? Now, if you do not decrease the window from the left and you move the R to here, what will happen is, you'll straight away reach till length 7. You don't want that, because max length is 5 and the next valid max length should be length 6, and then you'll get 7 and then you'll get 8, because you're moving the window. The window cannot jump from 5 to 7. The window has to jump by one place. So if I take the arm and move it here, the next length will be 7. And I don't want that. For that, in the previous algorithm, what I did was, I took this A off, till A was omitted entirely, and the L came here. And this was a valid segment of length 3, correct? And after that, I again started increasing R. 3 increased to 4, then it will increase to 5, then it will increase to 6, maybe. Now, what am I doing? I'm trimming it down to length 3. Is it required? Because from 3, I'll again have to go to 4, which I don't need. I straight away need something beyond 5, because I'm looking for longest. This is where I'll do the optimization. I'll say, there's no point in removing all the A's. Just remove one A and keep it as a length 5. And after that, when you have removed, keep it as a length 5 and then move R. So now when you move R to the next, the length is not 7, it is 6. I'm checking still for 6. And when I check, it says no. Again do the same thing, say, I'm going to remove just 1. So I'll remove 1. So what will happen is this 2 will become 1 and this L will go over here. And again, I'm keeping the length 5. After this, move R. When you move R, it goes over here. So this time D will come across, right? Imagine instead of D, this was C. Just imagine it was C. So C will be increased to 2. What will happen? It will be like, hey, listen, this is not a valid segment because we have 3. So again, we'll do the same thing. We'll just remove 1A. So when you remove 1A, this goes off. And when this goes off, the L from here goes to here. Now I'm keeping length 5 and this is a valid one. So what you can do is, you can increase the R And imagine there was another C, you would have increased it and you would have got the length 6 ultimately. So what I did was, I never allowed the 5 to go beyond 5 until this it was valid. It was valid at this scenario. So I moved here, now it is 6. Now I will not move L anymore. So the whole point is, there's no point in trimming down the window length from 5 to 3. There's no point. Keep it the window length of 5 now. It will help you out. So this is what I can do. Instead of removing all, like till I get a valid segment, just remove one. If it is exceeding, just remove one. That would do. And then you can have a check. If it's a valid, I'll update. Otherwise, I'll go ahead. Simple. And if I convert this to if, can I say that this big of n will go off? It will. And this is going to be a most optimized solution. Again, this is the pseudo code. In case you want your language specific code, you can find them below. So I hope if you're still now watching, you've understood everything. And if that is the case, please do consider giving us a like. And if you're new to our channel, do consider subscribing to us as well. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.